Hello students, last class we discussed about some organic conversion that are generally aliphatic compounds, and today we are going to discuss some organic conversion, generally some aromatic conversions. So you know that in conversion, in some cases the carbon atom increases, in some cases the carbon atom decreases. For aliphatic conversions, generally alkyl halide, the intermediate reagent, or in some cases carboxylic acids are the intermediate reagent. So in this way we can increase the number of carbon atom or we can decrease the number of carbon atom. Similarly, for aromatic conversions, in maximum cases, benzene diazenyl chloride or diazenyl salts are the intermediate reagents. So maximum conversion, the intermediate reagent comes as the benzene diazenyl chloride, and this is used for the synthesis of various organic compound. So in this way, you have to remember how this benzene diazenyl chloride is prepared, or from this benzene diazenyl chloride how you can prepare different compounds. Okay. Now let us start these conversions. Nitrobenzene to benzoic acid. So nitrobenzene, first you have to know all the formulas. You know nitrobenzene. So in benzoic acid contain one more number of carbon atom than this. In this way, so how we will go through this? Look at here. Nitrobenzene, when it reduced with tin and hydrochloric acid, it undergo reduction to form aniline. And this aniline, when treated with nitrous acid at 0 to 5 degrees Celsius. This nitrous acid, generally for nitrous acid we are using what? Sodium nitrite and dilute hydrochloric acid, so that it gives you this nitrous acid. So nitrous acid, so at low temperature, ice cold temperature, reaction is called the azotization. It forms benzene diazenyl chloride, N2 plus Cl minus. And when this benzene diazenyl chloride treated with copper cyanide in presence of potassium cyanide, so this is Sandmer reaction or copper cyanide, this is Sandmer reaction, it forms cyanobenzene. And this cyanobenzene, when undergo hydrolysis in acid medium or in generally or in alkali medium, this cyanide group is converted to carboxylic acid, benzoic acid. So this is the conversion of nitrobenzene to benzoic acid, and the intermediate reagent is benzene diazenyl chloride. Next come to question number 2, that is aniline to nitrobenzene. So aniline to nitrobenzene, this is very easy reaction. Okay, so from nitrobenzene to aniline, just you reduced by tin and HCl so that you can get nitrobenzene to aniline. Then again, how we can get aniline to nitrobenzene? Look here. So this is aniline, and this aniline, when treated with nitrous acid at low temperature, you can write temperature 0 to 5 degrees Celsius, or you can write 273 to 278 Kelvin. In Kelvin scale or in Celsius scale we can represent. So it forms benzene diazenyl chloride, and this benzene diazenyl chloride, when treated with hydrofluoroboric acid or tetrafluoroboric acid, it forms benzene diazonium tetrafluoroborate. So benzene diazonium tetrafluoroborate, this is also a salt, and here minus HCl. And when this is treated with aqueous solution of sodium nitrite, when this is treated with aqueous solution of sodium nitrite, it forms nitrobenzene. Okay, so this is conversion of aniline to nitrobenzene. Next come to question number 3. That is aniline to benzyl alcohol. Benzyl alcohol, you know, that is your C6H5 CH2OH. Aniline to benzyl alcohol. So aniline, when treated with, again here number of carbon atom increases, that means we should go through benzene diazoxide chloride so that it becomes easier. So aniline, when treated with nitrous acid at 273 to 278 Kelvin, that is ice cold temperature, this forms your benzene diazonium chloride, again treated with cuprous cyanide, and just warm it. So it forms cyanobenzene. Then this cyanobenzene treated with lithium aluminum hydride, it is converted to benzyl amine. And benzyl amine treated with nitrous acid. So aniline gives benzene diazonium chloride, but benzyl amine when treated with nitrous acid, it forms benzyl alcohol. So this is benzyl alcohol. Okay, with liberation of nitrogen and water. This is the conversion of aniline to benzyl alcohol. Next come to question number 4. That is toluene to 2-phenyl ethanamine. Toluene to 2-phenyl ethanamine. So first you should know what is the structure. 2-phenyl ethanamine means here also the carbon atom increases. In toluene 7 number of carbon atoms, here 8 number of carbon atoms. But here no requirement of preparation of benzene diazonium chloride. This is toluene, and toluene when reacts with 1 mole of chlorine in presence of sunlight, it forms benzyl chloride. Okay, and benzyl chloride when treated with potassium cyanide or sodium cyanide, nitrylation, the Cl group is changed to cyanide. So in this way the number of carbon atom increases. It forms CH2Cn. And this CH2Cn when reduced with either lithium aluminum hydride or sodium in ethanol, it forms CH2NH2. This is the functional group, and this is 1, 2 at 2 position phenyl. This is 2-phenyl ethanamine. This is toluene. So toluene to 2-phenyl ethanamine. Okay. Next come to question number 5. Benzene to aniline. So benzene, first for aniline we have to prepare nitrobenzene. In this way, when this is treated with nitrating mixture, that is concentrated nitric acid in presence of concentrated sulfuric acid. So minus water is there. Removal of water, nitrous acid, here a nitronium ion is electrophile substituted here. It forms nitrobenzene, nitration, electrophilic substitution reaction. And when this is treated with tin and HCl or iron and HCl, hydrochloric acid, then it is formed aniline. So this is benzene to aniline. Next, benzene to NN dimethyl aniline. So first benzene to aniline, first you have to prepare benzene to aniline. For question number 6, this is the repetition of some part of repetition of question number 5. Benzene to aniline. This is over. Then benzene to NN dimethyl aniline. So this is benzene to aniline, and this aniline when treated with methyl iodide. So here iodine and hydrogen is removed and minus HI. It forms NHCH3, N-methyl aniline. And then N-methyl aniline when again treated with methyl iodide, another moles of HI is removed and it forms NN dimethyl aniline. This is first benzene to aniline, then benzene to NN dimethyl aniline. Okay. So 5 and 6 are over. Next come to question number 7. Aniline to 135 tribromobenzene. So here this 135 bromination takes place, and another thing, this nitrogen atom is also removed here. So in this way, how to convert this? So this is aniline. You know this group is very much ring activating nature and orthopara dielectric nature. In this way, when this is treated with aqueous bromine water. But if this reaction takes place in bromine in presence of carbon disulfide, it forms a mixture of ortho and para isomer, monosubstituted. Otherwise, first this group, amine group, is first protected, then bromination takes place, then it also forms a monosubstituted product. But here, aniline reacts with bromine water. It forms 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. Remember your aqueous bromine water. And this, when treated with nitrous acid at 273 to 278 Kelvin, it forms N2 plus Cl minus, that is 2,4,6 tribromobenzene diazonium chloride. 2,4,6 tribromobenzene diazonium chloride. And this benzene diazonium chloride, when treated with hypophosphorus acid, aqueous solution of hypophosphorus acid in presence of a cuprous salt, this group is replaced by hydrogen and it forms and this diazonium chloride group is removed, so it forms 1,3,5 tribromobenzene. Okay, 1,3,5 tribromobenzene. This is aniline to 1,3,5 tribromobenzene. Next come to aniline to parabromoaniline. So for aniline to parabromoaniline, only mono substitution product is formed. If you take this bromine water, then tri-substituted product is formed. So to get this mono-bromo substituted, first we have to protect this amine group, NH2 group. So how this group is protected? This group is protected by acylation, or this group is protected by acylation reaction, or this is protected by acylation reaction either by using acetyl chloride or by using acetic anhydride. So when this group is treated with acetic anhydride, when this is treated with acetic anhydride in presence of sodium acetate or acetyl chloride in presence of pyridine, so it forms acetanilide, NHCOCH3. Now the activity nature of this nitrogen, this amine group is decreased, and when this is treated with bromine water, it forms parabromoacetanilide. It forms parabromoacetanilide. So this is parabromoacetanilide. And this parabromoacetanilide, again when undergo hydrolysis in presence of acid, when it undergo hydrolysis in presence of acid, H2H plus or write down H3O plus, so this group CH3COOH group is removed and it forms NH2Br, parabromoaniline. This is aniline to parabromoaniline. Next come to question number 9. Benzamide to toluene. So benzamide to toluene, there are different methods by which you can prepare benzamide to toluene. Look here. So this is benzamide. Benzamide when first treated with bromine and aqueous potassium hydroxide and warm, it forms aniline. And this aniline when treated with nitrous acid, this when treated with nitrous acid at 0 to 5 degrees Celsius, it forms this nitrous acid. It forms diazonium chloride, and diazonium chloride, when treated with hypophosphorus acid in presence of cuprous salt and water, aqueous hypophosphorus acid in presence of water, so it forms benzene. And this benzene, again when treated with methyl chloride in presence of anhydrous aluminum chloride, it forms toluene. This is one method. And another method also you can prepare. Look here. Alternatively, we can prepare easily. How? So this is benzamide. When this is treated with nitrous acid, so here bond breaking takes place. It forms carboxylic acid with evolution of nitrogen gas and water. It forms benzoic acid. And benzoic acid, when heated with soda lime, first sodium hydroxide, it forms sodium benzoate. Then this heated with soda lime, it forms benzene. And after this benzene, when treated with methyl chloride in presence of anhydrous aluminum chloride, it forms toluene. Either you go through benzene diazonium chloride intermediate step or through this carboxylic acid intermediate step. Okay. So this is benzamide to toluene. Next come to nitrobenzene to metabromophenol. Nitrobenzene to metabromophenol. So this nitrobenzene, this is meta-directing group. Nitrobenzene is meta-directing group. So when this is meta-directing group. So when this is treated with bromine, it forms metabromonitrobenzene. It forms metabromonitrobenzene. And when this treated with tin and hydrochloric acid, it forms metabromoaniline. And this metabromoaniline treated with nitrous acid at 0 to 5 degrees Celsius, then it forms metabromobenzene diazonium chloride. If the temperature is increased, directly it gives OH group. Otherwise, if to it you heat in presence of acid, actually the solution is more acidic nature. In this here, instead of this temperature, if you give more temperature, directly this is converted to metabromophenol. Or here, you go through this two steps or directly to one step. reaction with nitrous acid, temperature greater than 5 degree Celsius. It forms your phenol. Now let us discuss some other conversions. Benzoic acid to para-hydroxyazobenzene. So benzoic acid to para-hydroxyazobenzene means so first you have to prepare benzene diazenyl chloride which reacts with phenol to form para-hydroxyazobenzene. So how we can prepare benzoic acid to benzene diazenyl chloride? So this is benzoic acid, first treated with sodium hydroxide, forms sodium benzoate, heated with soda lime, forms benzene. Benzene undergo nitration, that is concentrated nitric acid and concentrated sulfuric acid. It forms nitrobenzene, and this nitrobenzene again treated with tin and HCl or iron and HCl to form benzene diazonium chloride, and this benzene diazonium chloride treated with phenol at low temperature, pH value in alkaline medium, that is 9 to 10, nearly about 9 to 10, and temperature is also low maintained, that is 0 to 5 degrees Celsius. It forms para-hydroxyazobenzene. This is benzoic acid to para-hydroxyazobenzene. First you have to remove this carboxyl group, then nitration, then intermediate benzene diazenyl chloride, then with phenol. Okay. Next come to question number 12. That is aniline to 2,4,6 tribromofluorobenzene. So how to convert this? Aniline treated with bromine water, aqueous bromine water. So it forms 2,4,6 tribromoaniline. Then this treated with nitrous acid. It forms 2,4,6 tribromobenzene diazonium chloride. Then treated with tetrafluoroboric acid. It forms 2,4,6 tribromobenzene diazonium tetrafluorobenzene. borate. And when this is heated, it forms 2,4,6 tribromofluorobenzene. This is aniline to 2,4,6 tribromofluorobenzene. Next come to question number 13. Nitrobenzene to N-methyl aniline. This is nitrobenzene treated with iron and hydrochloric acid forms aniline, and aniline treated with methyl iodide, it forms N-methyl aniline. Nitrobenzene to N-methyl aniline. Just two-step reaction. Here minus HI is there. Next, toluene to cyanobenzene. Question number 14. Toluene to cyanobenzene. This is toluene when treated with, when it undergo oxidation in presence of potassium permanganate in alkaline medium. What it forms? Benzoic acid. Then treated with, suppose, thionyl chloride or phosphorus pentachloride. It forms this is benzoyl chloride. Benzoyl chloride treated with ammonia. It forms benzamide. And benzamide when heated with phosphorus pentoxide, so minus H2O. This H2O is removed and it forms cyanobenzene. So this is toluene to cyanobenzene. Next come to question number 15. That is meta-nitroaniline to N-methyl aniline. NH2NO2, meta-nitroaniline to N-methyl aniline. So first this group is treated with nitrous acid at 0 to 5 degrees Celsius. What it forms? It forms meta-nitrobenzene diazonium chloride. Then this is treated with hypophosphorus acid in presence of cuprous salt. It forms nitrobenzene, and this nitrobenzene when undergo reduction in presence of Fe and HCl, it forms aniline. And this aniline when treated with methyl iodide, it forms N-methyl aniline. So meta-nitroaniline to N-methyl aniline. Next come to question number 16. That is toluene to para-toluic acid. So this is toluene. If oxidation takes place, it gives you carboxylic acid. So toluene, when undergo nitration, concentrated nitric acid and concentrated sulfuric acid, it forms the major product para-nitrotoluene. And this para-nitrotoluene, when reduced with tin and hydrochloric acid, it forms para-aminotoluene, or we can say toluidine. Then toluidine treated with nitrous acid, it forms para-methyl benzene diazonium chloride, and this treated with cuprous cyanide, it forms para-methyl cyanobenzene. This then undergo hydrolysis. It forms complete hydrolysis. It forms para-toluic acid. So in this way, it forms para-toluic acid. This is toluene to para-toluic acid. Next come to question number 17. Aniline to fluorobenzene. So this is aniline treated with nitrous acid. Temperature is ice cold temperature. It forms benzene diazonium chloride. Then this treated with hydrofluoroboric acid. It forms benzene diazonium tetrafluoroborate. And this, when heated, forms fluorobenzene. So this is aniline to fluorobenzene. Okay, so this conversion of benzene diazonium chloride to fluorobenzene, this reaction or aniline to this is known as Ball-Schiemann reaction. Next come to question number 18. That is benzene diazonium chloride to benzamide. So this is benzene diazonium chloride. Then this treated with cuprous cyanide. It forms cyanobenzene. Then this cyanobenzene, when it undergo hydrolysis. So when it undergo hydrolysis in presence of base or partial hydrolysis. Partial hydrolysis. It forms amide. CN group is converted to benzamide, or water in presence of hydrogen peroxide also gives benzamide. Otherwise, if you do complete hydrolysis, then treat with ammonia. Another step also there, I am writing here. So this is two-step reaction, or if it undergo hydrolysis in acid medium, complete hydrolysis, first it forms benzoic acid, and this treated with ammonia and heat, aqueous ammonia and heat, it forms benzamide. This is benzene diazonium chloride to benzamide. Otherwise, partial hydrolysis in 2 steps, otherwise in 3 steps. This is benzene diazonium chloride to benzamide. Next come to question number 19. Nitrobenzene to para-amino-azobenzene. So, this is nitrobenzene reduced with tin and hydrochloric acid forms aniline, treated with nitrous acid forms benzene diazonium chloride. Then this is again treated with aniline in some acidic medium, slightly acidic medium, pH 4 to 5, slightly acidic medium. Temperature is also same, low temperature is maintained. It forms para-amino-azobenzene. Next come to question number 20. Aniline to metabromo-nitrobenzene. This is aniline. If aniline directly bromination takes place, then it forms 2,4,6. If this group is protected, then para product is there. But the product is given meta. But you know nitro group is your what? This nitro group is your meta-directing group. In this first NH group is converted to nitro group. So how this is converted to nitro group? Aniline treated with nitrous acid forms benzene diazonium chloride, treated with HbF4 hydrofluoroboric acid forms benzene diazonium tetrafluoroborate BF4 minus, and this when treated with sodium nitrite, it forms nitrobenzene, and nitrobenzene when treated with bromine in presence of FeBr3 or simply bromine in presence of iron. Bromine in presence of iron or FeBr3, it gives metabromo-nitrobenzene. So these are some conversions. Next class we will discuss about some analytical questions.